Hey guys, all right, jumping right back into section 13.3, we are zooming in from the urinary system to look at the kidney. Okay, so this is the main organ of the urinary system. So let's take a look specifically at the kidney and what is going on inside of it. So inside of your body, each of you have two kidneys on your right and left side. The kidney is supplied with an artery that provides blood into it that's being filtered, and then blood that is coming out of the kidney. So anytime you see this red vein, that means that is oxygenated blood coming in. And then blood coming out is the renal vein. It's deoxygenated. Now, also in that blood coming in are going to be all of those toxic waste products that are being brought in from the liver. So ultimately, your kidney can filter out those waste products, place them into the urine for your body to then get rid of them and excrete them down through the ureter, into the bladder, and out through the urethra. Okay, so when we look specifically at the internal view of the kidney, we have the outer area being the cortex, and then you have these inner little pockets that we call the medulla. All right, now, a very specific area that's in between the cortex and the medulla is something called a nephron, okay? And then, of course, we have your ureter that branches out from the kidney. So once filtration has taken place, this is where everything exits. All right, so let's go ahead, and just so you know, this will be in your notes, waste substances that need to be removed from the blood: excess water, excess hormones, urea, creatine, ammonia, uric acid, and then any type of excess salts or ions listed here. And again, that'll be provided for you in your notes. Okay, now when we look specifically at the nephron, so this is the really the filtering units that are in between that cortex and medulla area in the kidney. We are going to have, and just so you know, in American science, we really just call it the nephron. But in this particular curriculum, you may also see it labeled as a kidney tubule or a renal tubule. So just be able to know the vernacular if you see it listed as both, okay? All right, so let's go ahead and break down the structure of the nephron. The nephron, we have the first point of contact with blood at the glomerulus that is surrounded by the Bowman's capsule. Then we have the proximal convoluted tubules. We have something called the loop of Henle, and it's a big loop. Henle is the man that discovered it, so it's the loop of his name. And then the distal convoluted tubule, followed by the collecting duct, where everything collects at the end. All right, so let's see kind of what's going on inside of that structure as far as filtration is occurring. Now, we call this ultrafiltration. If you notice, and we've got blood from the renal artery coming in, and we are going to have, they depict it with these little green arrows, okay? So this blood has all of your waste products. They hit the glomerulus first, and then those materials move into the tubules that form into the loop of Henle, and this, remember, is the proximal, and this is the distal, and then the collecting duct. But all around these are capillaries that can absorb the different materials, specifically where they land in each part of the nephron. So there's a lot of images here, and the next one that I will show you is a little bit more specific of giving you a visual of how this reabsorption is occurring. A great table to use in your notes that you will have is this table right here. And again, I'll show you the visual in just a second. But for the components, water, salts, glucose, and urea, you really need to know where those are reabsorbed back into the bloodstream. So everything coming in your blood is not necessarily bad for your body. If too much of it leaves your body, you can start to have a problem. We'll talk about how diabetes comes into this talk in just a little bit. But ultimately, water is reabsorbed at the loop of Henle in the collecting duct. Salts are reabsorbed at the loop of Henle. Glucose is reabsorbed at the proximal or first convoluted tubule. And urea is not absorbed. Not reabsorbed. We need urea to stay in the nephron tubule to be excreted through the exit through the ureter into the bladder and out the urethra. Okay, so again, here's that picture I kept telling you about. I'm like, okay, this is the one that's going to be a little bit more or a little easier to understand. All right, so the different arrows indicate what is leaving and what is staying. So the green arrow indicates the filtrate. So this is the liquid material where everything is going to leave the body eventually that ends up in the filtrate, okay? So when we have the filtrate that meets here at the glomerulus, you can see that the glucose is then leaving at that proximal convoluted tubule, the first tubule. Now, glucose is going to be reabsorbed into the bloodstream because remember, this red little tube here is like a capillary. It is going to be reabsorbed by active transport. All the rest are going to be passive transport, either diffusion or osmosis. Okay, so glucose is leaving here, and then we see the filtrate comes down into the loop of Henle. This is where salts and water are going to be reabsorbed into the bloodstream, again with those capillary beds that are surrounding it. And if you're looking at salts, that's going to be reabsorbed by diffusion. If you're looking at water, remember water will be reabsorbed by osmosis, because if we're dealing with water, it's osmosis. And then that filtrate continues on through the distal convoluted tubule. Water can also be reabsorbed here, but ultimately the urea is still in this collecting duct, which will then pass into the ureter, stored into the bladder until it's like, oh, can't hold it anymore, I need to go, and your body will get rid of it through the muscle contractions of your bladder. Okay, so let me see if we have anything else. Again, these will all of this will be listed in your notes that's here. You can pause the screen and read through this if that would be helpful for you. But again, I'll provide some notes for you. The next thing that we'll talk about is kidney failure, because we need to understand what's going on there. Important to note before I forget, people with diabetes cannot control their blood glucose levels, because remember that glucose is being transferred in that first tubule through reabsorption by active transport. If that glucose cannot be reabsorbed into the blood correctly, this leads to that disease that you've probably heard of called diabetes. So very important job of our kidneys to keep us healthy in that sense. But other than that, head on over, get your notes down, take your CFU, and then move on to any of the day's activities. You are doing great. Good job, guys.